All right, let's take a look at the next set of practice problems here. Exponential expressions, word problems, algebraic style. On the day that a certain celebrity proposes marriage, 10 people know about it. Each day afterward, the number of people who know triples. So in this case, triples is the key word here. This is not an example of exponential growth based on a percentage growth. It's not greater than 100%. This one's giving you an actual growth factor. It tells you that it triples. So with these problems, we always start with our initial value. So that's going to be 10. Inside the parentheses is our growth factor. We've just told that it triples, so that is raised to the third power. And then we need to raise that to the exponent. Oops, I typed that in wrong. Got to raise that to the exponent. In this case, they told us the exponent is t. So we type that in, we check it, and there we go. All right, next one. There are 170 deer on a reservation. The deer population is increasing at a rate of 30% per year. Write a function that gives the deer population p of t on the reservation t years from now. This one is an example of our percent growth. So if it's increasing by a rate of 30% per year, we need to take 100% plus 30%, which is 130%. If we write that as a decimal, it is 1.3. So our initial value is 170. Inside parentheses, 1.3. We raise that to the exponent they told us to, which in this case is t again, and we check our answer. How about the next one? Mapaya writes a series of novels. She earns $75,000 for the first book, and her cumulative earnings double with each sequel that she writes. Write a function that gives Mapaya's cumulative earnings, E of n, in dollars when she's written n sequels. Do not enter commas in your answers. Okay, so our initial value for the first book, she made $75,000. Again, this is not an example where we add anything to 100%. They gave us the growth factor at double, so that means it's going to be 2 inside parentheses. They want us to raise it, in this case, n, for the number of sequels. So we raise that to the n power. We check our answer. In 1950, the per capita gross domestic GDP of Australia was approximately $1,800. Each year afterwards, the per capita GDP increased by approximately 6.7%. So since this one is increasing by 6.7%, this is a percent increase problem. 100% plus 6.7% is 106.7%. As a decimal, that's 1.067. So we go and type this in, 1800 in parentheses, 1.067, because that's 106.7% as a decimal. They want us to raise that to the t power because it's t years. And we check. And there we go. 4 for 4.